All right, so we're going to take a look at the partner quiz for filling and wrapping here. A chocolate company sells chocolates of different sizes and packaging shapes. The packages below are in the shape of a triangular prism, Toblerone, sorry, where the bases are equilateral triangles. And so we have the shapes there. Great. How many square inches of cardboard are needed to make the smaller package? So when we're talking about square inches, right now that should tell you we're talking about area. And in particular, area of three-dimensional shapes is referred to as surface area. So here we go. To find the surface area, we need to find the area of all of the faces. And a triangular prism has 5 faces, not 6. And so what we're going to do is we're going to write the area of each on the actual face. So let's pull up our calculator. Excellent. And a couple formulas we need to know. The area of a rectangle is equal to the base times the height. And the area of a triangle is equal to the base times the height, all divided by 2. All right. So let's find the area of the front and back. So we have 4 times 3.46 equals, and we'll divide that by 2. And so we know, yes, you need to write out every step. So we know that this area right here is 6.92, which means the area of this face right here is also 6.92. All right. On this face here, well, we know that this length here is 8.25. And what do you think this is? It's not labeled. Well, let's look at the instructions and see if it gives us a clue. Oh, equilateral triangles. Well, that means that this side length right here has to also be 4. Okay, so the area of this face is going to be 4 times 8.25, which equals 33. Now, because we have an equilateral triangle, we know that this face will also be 4 times 8.25, which is 33. And the same thing for this face here. So now it's time to add all of these things together. So we have 3 faces of 33, 99, shocking, plus the front, which is 6.29, plus the back, which is 6.29, and we get 112.84, and it's inches squared. All right, not too bad to start. Put the calculator down here. Okay. So I'm going to clear this and then I'm going to scroll up. All right. So how many square inches of cardboard are needed to make the larger package? All right, so we have 2 ways of going about this. One way is to do the same thing we did before. Find the area of the faces, and that's great. But I want to do it a quicker way. Now, we previously had an area of 112.84, I believe, inches squared for the smaller figure. And for the larger figure, what is the scale factor to go from small to big? Well, the scale factor is, well, the question is, what did we multiply 4 by to get 16? And so the scale factor is 4. Now, what is the connection between scale factor and how many times larger an area is? Well, it's the scale factor squared times bigger. Well, why is it scale factor squared? Because we're dealing with square inches. Because area is in 2 dimensions as opposed to a side length, which is just 1 dimension. So that means if we multiply our original area times the scale factor squared, we will get the new area. So the scale factor, well, 4 squared is 16, right? So I'm going to multiply that by 16, by the original area by 16, and I get 1,805.44 inches squared. How many cubic inches of chocolate will the smaller package hold? Well, I know that the volume of a prism is going to be the area of the base times the height. Well, we already found the area of the base. This was 6.92, I believe. And so times the length here. So I'm going to pull out my calculator. And so we have 6.92 times 8.25. And so my volume is 57.09 inches to the third power. Now I just want to make sure that I had that right, because I hate to give you a wrong answer and then you have to hear about it tomorrow, of course. Times 4 divided by 2. Okay, I did remember correctly. Love it when that happens. All right, and so now let's go and see if we have any more. Oh, shocking. It's the same question, only now it's with blue, and so now it's with how many cubic inches of chocolate will be in a larger package. Now, there are two ways to do this again. I can again find the area of the triangle multiplied by the height of the prism, and that will get me my answer, and there's no shame in that. But I kind of want to stick with the scale factor idea. So if the scale factor squared is how many times larger the surface area is, and that makes sense, again, because surface area is two-dimensional, what will I have to do with the scale factor for the volume? Well, the volume is in 3 dimensions, not 2. Therefore, if I take my original area and I multiply it by the scale factor cubed, remember those, the 1, 2, 3 boxes with the worms, I will get my answer. Now the scale factor cubed here is 4 times 4, which is 16, times 4, which is 64. So I'm going to go 64 times 57.09. And oh, lo and behold, I get an answer that makes no sense. So let's try it again. So 64 times 57.09. And so I get 3,653.76 inches cubed. And there's my answer. All right. Suppose a smaller package sells for $2. The smaller package sells for $2. What should the price of the chocolate in the larger? Well, so chocolate should be priced by volume, because the volume of the chocolate bar tells you how much chocolate has been used. So if we're using $2 for the smaller, and we know that the volume is 64 times bigger, my goodness, that's a lot of chocolate. A lot of money. So we would get $128. And that doesn't seem quite right, but there you have it. Okay. Suppose other possible packages are prisms with lateral faces that are the same size as the original smaller package, 4 inches by 8.25 inches. What package shape would hold more chocolate than the original smaller package? Suppose, let's reread that again. Suppose other possible packages are prisms with lateral faces that are the same size as the original. So the lateral faces, so that is the sides, right? So if I go back here, the lateral faces define these rectangular faces here. So here's a lateral face, and then here's a lateral face, and then here's the other lateral face. So you have 3 lateral faces. I'll just color code them. And so the lateral area is going to remain the same. So really, the prism that we're going to have is going to change by the shape of the front. Okay. So, let's see what the question is. What shape would hold more chocolate than this original smaller package? All right, so we know to have that lateral area, each side is going to have 4 and a height of 8.25. And originally we have a triangle, right? Well, what shape of the base, assuming the lateral area for each side is going to be the same, could give us more chocolate than the triangle? Well, I'm willing to bet if I have so close. Would a rectangular prism have more chocolate than the triangular prism if I kept the length and the height the same? You better believe it. It would double the amount of chocolate. Well, why stop there? Why stop with 4 faces when you can have 5? Would that have more chocolate than the shape with 4 sides? Yeah, it would. Well, what shape wouldn't, right? We keep adding more sides, we'll get more and more chocolate. So therefore, any prism with the same lateral side lengths will have more chocolate than the Toblerone triangular prism. Okay, that was sort of a tricky, weirdly worded question. In Japan, growers have developed ways of growing watermelon cubes that fit into small refrigerators. That seems bizarre to me. All right, suppose you cut one of these watermelon cubes open using only one cut. Which 2-dimensional shape would you see on the cut surfaces? And explain your answer. Well, it depends, really. If I cut here, that's the wrong thing. If I cut here, I will get a square. But if I cut here, and have sort of a diagonal, but not all the way to the edge, I will get a rectangle. But what happens if I just cut off an edge? Let's go to yellow. What happens if I cut here? I would end up with a triangle. So I could either have a rectangle, a triangle, or a square, depending on how I cut my watermelon. Watch out. Beware of the watermelon, because watermelon eating will produce a dopamine response in your brain. Very, very controversial.